So this is the American-made Solar Prize. It's put together by the Department of Energy, and it is to encourage in the solar manufacturing, but also the industry at large, to inject innovation. And they've been doing several rounds of these contests. This is the 5th one. And I think this one is $3.6 million, something fairly substantial. These contests are for big ideas, concepts, but they can be done by very small ideas. So there can be something we've seen, and we've had winners in several of these similar contests for government agencies, that achievable ideas that individuals come up with that didn't have a big background have been successful in moving forward. And then there's infrastructure to support that, those efforts moving forward. So this contest is broken into 2 tracks. There's a hardware track, and hardware is really broadly defined. It can be any physical thing that interacts with the solar industry. I was in another webinar and they said, can that include things in space? And outer space is fine. So that's inbounds. So it does not have to be really limited. And what we're trying to do at this level is just a proof of concept. We're building a plan to develop the proof of concept. So you just have to have the conception of how you would get there. So you don't have to have a really developed thing at this point. And then there's a software track. And in the software track, they're looking for ideas for new software. It could be in addition to things, but they're not looking for an expansion of like a big software package. They're looking for new software ideas that can be prototyped and then brought to a market and eventually have customers. So these can really be anything related to advancing the solar industry. I'd mentioned that these 2 tracks have different levels. We're at the ready level, which is the top red bar. Each of these 2 tracks will get 20 winners. People in the hardware track will each get, or teams will each get $50,000 to recognize the work they've done to get ready, and then give them the resources to go to a proof of concept. And then they'll go to an actual prototype if they get through the next 10 winner stage with $100,000. The software track has the 20 winners at $30,000 each. Software is a little cheaper, and then 60, and then up to 200,000. But it also has a additional contest that only the software side can do. That's about justice, equity, diversity, and inclusion. So if your software idea can help to address those, help to bring solar to people who have traditionally not been able to get those things, have been underserved, that can get an additional $10,000 to $30,000 just in this ready level for your proposal that you will submit. And these proposals are not huge. They're 2,500 words. So the goals of our activity today is we're telling you about this contest. We're going to brainstorm, generate some ideas. We're going to talk in a group about those and hopefully have 1 or 2 90-second pitches. And that will set up teams to actually submit or identify more resources that they need to be able to do a submission. And just to get your brains moving, we're thinking about problems. So there's lots of problems, right? So solar panels aren't perfectly efficient. Their energy is wasted through heat. There's lots of spikes and dips in when the energy is generated, but also when it's needed, which means that the storage of energy is a concern, but it's still very expensive to be able to store, transmit, and manage that energy. Aligning all the various systems are expensive. Solar farms and other generation sources can sometimes be far away from where the cities are, where the energy is needed. Installing it can be expensive, and we'll learn more about some of the potential challenges or situations where it's better to install. There's maintenance costs. Manufacturing is often done overseas, and there's just a lot of complexity in this like incumbent system of how we distribute and purchase energy that the solar generated energy has to deal with. So in order to help us understand the pain points and to get just a better perspective, I have invited Brennan Smith from Sunlight Solar to be able to chat with us. So I'm going to stop sharing and allow him to give us a few minutes on his perspectives.
All right, thanks, JR. Thanks for inviting me to this. It sounds really cool. So yeah, I'm Brendan Smith from Sunlight Solar. So we're a local solar installer. So we don't manufacture any products. We are more of a product integrator. So we're also known as an EPC, engineering, procurement, and construction. So we handle, the basic engineering requirements to install a system, and then jumping through all the hoops for permits and interconnecting that with the utility company. We've been in Connecticut since 2004, which, that doesn't sound like a long time, but for the solar industry, that's a very long time. My specific role is I'm the design and sales manager there. So, there's basic sales management role. I do commercial sales, but I also am kind of the bridge or the go-between between the technical design people and the salespeople, making sure that, what salespeople design is something that, or what salespeople sell is something that can actually be installed. What else? So I made just a really handful of things just from brainstorming with a couple of my coworkers on problems that we have, both big and small, long-term and short-term. I'll just rattle those off. I'm kind of interested in your questions if you have any, because it's easy to get tunnel vision when we're just, working on spitting out solar, deploying solar. So maybe I don't even recognize the problems that we're facing. So, I mean, yeah, like I said, aside from just deploying solar faster and cheaper and keeping it reliable. I should mention, we also are installing battery storage as well. So that's fairly new to the scaled up industry, but lot of room for improvement there. So on the hardware side, well, not necessarily hardware, maybe this is process engineering, but module recycling. So solar module recycling. There are firms out there, I believe, that do it, but we recently had a conversation with the Connecticut Green Bank, and they had hired a recycling firm, and it was something on the order of $75 per module, which, if a solar module costs $400, that's like 20% of the cost, the original cost to recycle it. So I have no ideas for you how that would be improved, but there's definitely room. Kind of on the other end of the perspective, a lot of the work, not a lot of the work, but a lot of the kind of maintenance or service work we do is when roof shingles need to be replaced on residential roofs, removing the systems and then replacing them. So if there's, products that can either make that easier or ideally make it so that you don't have to remove the system in order to re-shingle the roof, that would be something. I've given this just a little bit of thought, but making it cost effective is also important, because it can be quite costly to completely remove a system and replace it, because a lot of times you're basically replacing a lot of the hardware that is installed with it. But one thought was, if you had a nice rectangular array, perhaps when you install the system, installing it on like a standing seam metal roof, so that, and flash that into the shingles, so that when you come back to replace the shingles later, you shingle around that footprint, and then you don't have to remove any equipment. Just a thought. The other thing is, so there are a handful of positively grounded PV modules, namely SunPower. Older SunPower brand modules are positively grounded. Most are negatively grounded. And so if you have positively grounded modules, you have to have a positively grounded inverter. So we're having a really hard time finding replacements because there aren't really any positively grounded modules anymore. So again, I don't know what the solution is. Somebody could come out with just a retrofit inverter, or some way of converting. And then on the software side, the only thing I could come up with was something to estimate or predict the demand reduction component to PV's production. I don't know how much detail I have to go into that, but particularly on commercial systems, there is both a consumption component. So that's just, the spinning of the meter, the counting the kilowatt hours that you're using from the grid. Pretty straightforward to model. The other side to it is commercial bills will charge for demand spikes. So they will look at the highest one-time spike of power use over a 15-minute window anytime throughout the month. And so if you imagine if that spike is at noon on a bright sunny day, solar is going to have a big impact on that spike. But if it's at 6 in the morning, or it's on a cloudy day and it only takes one day for that to happen, solar is going to have almost no impact on it. So when we do a commercial proposal, we basically just have to ignore the savings that could be seen by reducing your demand spikes. There very well might be software out there that already does this. So obviously on any of these thoughts, do your research. But if there's a bankable estimation software that would be attractive to particularly commercial finance, solar finance companies, because if they can accurately predict the savings that you can see on the demand spikes, then they can charge more for the power from the systems.
So, a question about the demand spikes.
Yeah.
Is it completely instantaneous or over a period of several minutes? How is that built out, and what's a typical impulsiveness to it? Like 1.25 times as much as your average use, whatever.
So the two main Connecticut utilities, they look at KW in KW units. They give you the first 2 KW for free, and then after anything beyond that, they charge you per KW. And it's, I believe in UI territory, it's over a 15-minute window. So like an average of the spike. And then I think in Eversource, it's over a 30-minute window. So yeah, there are softwares that are designed to use energy storage to kind of mitigate that spike. And those exist. I really don't know if there's room for improvement on those. I'm sure there is, but that's intended to reduce those demand spikes by, pushing power out of the battery when it detects a demand spike rise. But I haven't seen, and again, it may exist, but I haven't seen a piece of software that's going to look at, a model of solar production throughout the year and an estimate of roughly how much just a regular PV system is going to reduce those demand spikes. We definitely see that it does, but trying to predict what that will be is just a shot in the dark. So we don't even, give people an estimate of what sort of savings they'd see there.
Yeah, we definitely need, some historical electrical demand data to, take much more than a random guess that really hot days in the summer in the late afternoon are probably some of the highest. But other than knowing when peaking generators actually flip on, it wouldn't be that straightforward.
Yeah, and it's really case by case on the building and what they're doing in the building. So we have a small manufacturer that we put a solar PV system on. He doesn't have any storage, but his workers come in at 6 a.m. Flip the switches on all the machines, power up everything all at once, and that's his demand spike every time. And so solar is going to have almost no impact on that. So he's worked to try and schedule when they start pieces of equipment and wait, in 15-minute increments. I'm sure that doesn't always work. It only takes one day where people don't do that, and then you get a spike, and then you're paying for that spike.
Great. Were there other questions? We have time for one or two more.
Oh yeah.
Hey, I was curious about solar efficiency in the winter, particularly when there's if there's snowfall, how long you'll see that dampening solar output in your installations, and if there's equipment or ways of managing that people typically employ.
Sure. Yeah. It definitely does impact production to some degree. If the panels are covered in snow, they don't produce anything. So we try to include that in our production estimates. Just plug in a certain number of days where the system will be down into the software. Really, it's not that big of a problem though, because just anecdotally, I have solar on my house, and I've been telling people for years, don't worry about the snow. Don't try and get up on your roof and sweep the snow off. It's not worth it's not worth injuring yourself. So as soon as I started a winter with solar, I saw the snow on the array, and I was like, I got to get that snow off of there. So I first went to go find a roof rake or a roof snow removal shovel. Those are $50, and I started doing the rough math on what's the payback on this $50 snow rake, and my production from a 5 kW system amounted to something like $1.75 a day on a bright sunny day. So it's kind of a long payback on a snow shovel. So it's not a huge big deal. It does impact things. It probably impacts it on commercial roofs more because you don't shed the snow as quickly, and maybe at higher latitudes, it's a larger piece of the annual production. But here in Connecticut, it's not really that big a deal.
Got it.
Was there? Hi. Was there another question?
Yeah. Are you folks also looking at the manufacturing of these solar panels in terms of the raw material? I think the cost now is $0.50 per watt, I guess. Are you looking at improving the kind of manufacturing of these solar panels?
So we don't work on the manufacturing side. It's definitely obviously something that's attractive to us because we're practically I think JR pointed out, we're practically the end user. We're one step away from the end user. So if there's manufacturing processes that can bring the cost of solar down, that's always attractive to everyone in the industry.
Hi, this is Mike Rohr. I imagine 90% or more of the solar panels that we use in the U.S. are made in China. Is that still correct?
Yeah.
Okay.
Oh, no, go ahead.
Yeah, I was visiting a plant in India a couple of years ago down in the south of India. And they make these solar panels out of the husk of rice. Rice is a staple crop in India, but they remove the silicate from the husk of the rice and then create panels which are much cheaper than the traditional ones.
They're using it to make the silicon crystal cells,
Yeah,
solar cells. Wow.
That seems really counterintuitive. So they're getting sand out of corn husk and then using it.
no, not sand, silicate.
Yeah.
Silicate.
Silicate.
Yeah, so when you
Main
remove the
ingredient of sand that you, okay.
yeah, I know. Yeah, but this the husk has some amount, and they can bring out some amount to build the solar panels. They have been successful, and they have built those. And India has a good sun number, as they call.
So the question I wanted to ask, trying to tie together some of the issues that you raised. Right, did you have more to say, Ham?
Yeah, the other thing is JR mentioned about positively grounded panels. And presently I'm teaching a graduate level course in power electronics. And that covers all the aspects of inverters, rectifiers, DC-DC converters. And I'm actually writing a book on that. So I have other books that have been published on this topic, and some of them are on Amazon. So if that project or that problem is to be handled, I can always use it as a project for my students.
Oh, great.
Yeah, I mean, it's a bit of a niche because off the top of my head, I actually can't even think of another solar module manufacturer that does positively grounded other than SunPower. And they've stopped. They've stopped since then. But it's kind of a headache for us. A lot of times we're sourcing like refurbished inverters off the internet, eBay and whatnot, because there aren't really manufacturers that are manufacturing new positively grounded. It's probably that there's not a whole lot of money in there as a full scale inverter manufacturer, but maybe there's some sort of niche that would be worthwhile.
So I think that we have Mike and then Bob, and we should move into our next phase of brainstorming. Maybe after those, it seemed like Bob had a question because I saw you on mute, unless there's any other burning questions. So Mike, do you want to finish your question?
What I wanted to ask is that, several problems are related here. One, we're losing a lot of manufacturing capability in the US. We were making solar panels, but China was able to undercut us, and maybe government subsidies, whatever the reason, it certainly killed the U.S. solar panel manufacturing industry. But I was thinking about the other concern that you had too, that I wondered why we couldn't combine a solar panel with a roof shingle. So the same size, a modular way, you connect them together like Lego blocks, and you wouldn't have to replace both because you would replace them, at the same time. Is there some technical reason why that couldn't be done? And the reason that I was thinking about it was that, and this happens with most things become commoditized. And that is something that hits a certain usage level. Price becomes the only object. So somebody who's an installer to bid on a project is going to look for the lowest cost solar panel. But perhaps a solar panel that costs more made in the US that has other benefits, like not having to replace the shingles or to remove the solar panels to replace the shingles because there are other shingles. You see where I'm sort of heading here.
Yeah,
we might have a competitive advantage.
Yeah, there have been quite, I shouldn't say quite a number, but there have been solar shingle products out there. When I first started, Certainteed had one. That's a roofing material manufacturer. I've seen Dow had one, 3M made one, and then a lot of people know Tesla has a solar shingle or a solar roof tile. And what they seem to always run into is they're costly, so they cost more. But like you said, you're also replacing the roof at the same time, so you can work that into the cost. But in a lot of cases, it still outstrips the cost of just replacing a traditional roof and then putting traditional crystal modules on the roof. And then also they tend to be less efficient, so you need more of them. So you need more of them, and they cost more. So you might not have enough space on your roof to produce what you need with solar shingles.
Good. Thank you.
Yeah, and the times that I saw those cut sheets for the solar shingles, the efficiency, which just didn't keep up with the panel. I mean, they look nice.
Are you in the solar industry?
I am. I'm with Posigen. If I'm looking,
right on.
You're with Sunlight Solar.
Sunlight Solar. That's right.
Oh, okay. I've spoken with your owner, Paul Israel, several times over the years. So he's got a great operation. You guys have a great operation there.
Yeah. Thanks.
You
guys have kind of cracked the low income market. Or I shouldn't say market. It's it's serving a good purpose. It's great.
Yeah, we with the Solar for All program that we have at Posigen, we try to write half of I should say we're required to write half of our deals in the low to moderate income neighborhoods in the state of Connecticut because they've always been boxed out of these good opportunities because it was just too costly. And when you strip all of those barriers out, that's why you're seeing in the LMI neighborhoods more and more solar going in. So, but getting back to the roof panel, we have a product that we use in our Deco Tech division. It's a product put out by GAF that is it's kind of similar to a roof shingle where we're doing the entire roof at the same time, but it's not it's a panel integrated into the roof system. So it's there's no traditional racking that's standing off. It's kind of built into the system. I haven't seen. You can Google some of the stuff, some of the installations. It's pretty fascinating, their installations, but I haven't seen a system up close and personal and read the cut sheets on it. It's a different division than I'm in, but it's heading towards that direction of a solar signal.
So I know there's more questions, but I think we do have to move on to our, to keep with our timeline. We have to move on. We are going to break into more discussion afterwards. So I think I'm going to just pause it there if we have everyone. So I'm going to bring us back to the presentation where we'll start going into some brainstorming. So I actually have a activity. And as was mentioned, sometimes we can get these blinders on where you're only thinking of one set of solutions or what you're very familiar with. And so this exercise is intended to break out of that box. What I want everyone to do is, and I'll tell you to start in a moment, to silently and quickly write down as many wild, including bad ideas as possible. And if you feel stuck, your target should be like at least 10 ideas. So not one great idea all described, just a phrase that helps you to remember what an idea is. If you're stuck, we have a bunch of prompts up here. So for example, what if solar is underwater? Maybe that's ridiculous and has no application, but you just think about, well, what would I do if I had to have part of it underwater? It might give you some idea about floating pads out at sea. What if it was interactive? Well, now you're thinking about maybe it's software side interactive, maybe it's the panel itself is interactive in some way. So I'm going to ask everyone, you can pull up Notepad on your computer and do this, or you can use a physical notepad. But I'm going to time, a minute or two till I see people look up, and ask you to go through this quick brainstorm, 10 ideas real quick. With us is Mike, who's been participating. And just to give a shout out to the Entrepreneurship Foundation, who partnered with us on this event. And for those teams that submit a full application and are willing to CC or copy that application to MakeHaven, so we can make sure it's a full qualified application. There's a up to $500 per team reward recognition for being one of those who have participated and submitted. And that's open to any CT-based team that was involved with us and this presentation, whether here or in one of the follow-ups. So Mike, with that introduction, and thank you, do you want to say anything about the Entrepreneurship Foundation?
Sure, thanks, JR. So these have to be, these proposals have to be in by, you said October 5th?
Correct.
That's the deadline. It'd be great if we do this again, if Hem could extend that to his students, if any of his students wanted to put that to, proposal together. So if the feds do this again, that'd be great. I don't know how Hem feels about it, but it might be an incentive for his students to work on some projects as well. But I just want to let you know that the Entrepreneurship Foundation has a stable of mentors. We run business plan competitions. We have networking events with other entrepreneurs, attorneys, investors, and other folks that provide other resources that you may want to access if you want to follow through on any of these ideas or your own. So we're around. We're in the book, entrepreneurshipfoundation.org. And I'll put my email in the chat if there's anything that we could do for you. If you want to start a business around one of your ideas, we have some resources that can help. Just talk to us about what you need.
Thank you, Mike. And thank you for supporting this. And I think it's great that we're incentivizing and recognizing that people will work on these applications. And we've seen people win from MakeHaven. And I know if we get more people submitting, we'll see more startups get some wind behind them. I just wanted to mention MakeHaven for those who haven't been there. This is a layout of the space. We're there to help you develop your prototype. So we have lots of expertise, people that work in electronics, 3D printing, laser cutters, woodworking, CNC, and even metalworking. So you can make the brackets and all of various things in prototype with volunteers that help teach you how to do it. So we're there as a resource, and we want to help you get your successful next stage product out the door. So again, this is the last slide, but it's October 5th at 5 p.m. Eastern Standard Time. There's a 90-second video that can be a very simple video that you submit. You send them a link. There's a cover page. There's the problem, solution, team, and plan, limited to 2,500 words. You get an extra 500 words if you're adding the software Jedi response. You are also going to have to go into their little online tool and say what resources you need. It's a few options, takes a few minutes. There's a summary PowerPoint slide that could have your drawing that you did or an improved version of the drawing. And then there's letters of support, which are optional. And you might come to folks like MakeHaven or others who would say, we would be happy to help you work on building a prototype. And so with all of those things together, you can put in a submission and potentially win tens of thousands of dollars towards an idea. So if you choose not to do it, please share this information with others who might be excited and let them know the resources at MakeHaven and the Entrepreneurship Society where we can help you get to that place.